This video is an introduction to Tinkercad. So the first thing you want to do is go to tinkercad.com and you're going to create a free account. Now I already have an account, so I can just go ahead and sign in. Okay, so now that we've created an account and we've signed in, we're going to go to Circuits. Okay, so there's different options over here, but we're going to start with Circuits. And you can see I've got a couple here, or maybe a few, but let's go ahead and just create a new circuit. So we're going to create a new circuit, and Tinkercad will give it kind of a unique name here. I'm just going to leave that name for now. And the first thing I'm going to do is I'm going to come over to where it says components, where it has basic, and I actually want to go ahead and just list all components. So instead of just basic, I'm going to list all the components. Even though we're only going to be using a few components, we're going to be using resistors, and we're going to be using a breadboard, which is here. So I'll go ahead and left click and drag my breadboard, and we're going to be using a power supply and multimeter. So let's go ahead and create just a basic series circuit consisting of just resistors. So the way you want to place a component is you left click and drag. So using your mouse, you want to left click and drag and place the component. Okay. Now, if you want to zoom in and out, you can use your mouse wheel to zoom in and out. And if you want to rearrange a component, you can left click and drag. And in this case, I need to rotate this, because you can see that right now the resistor is shorted out because these are all connected vertically. So I'm going to use the R key to rotate it, and this is much better. So now I've got this resistor that is placed in a proper orientation. Now, one of the neat things here is when you hover your mouse, you can see all the connections. You can see that this rail is all connected, this rail is all connected, these vertical columns are all connected, and same thing on the bottom rail is connected here, and these vertical columns are connected, and they're separate from these up here. So this gap in between separates the, say, column 19. These are all connected, but then these are connected here, but they're not connected to this top one. So there's an isolation here. Okay, so let's we're going to do a simple just 4 resistor. So let's left click, drag, and rotate. And let's connect this resistor by putting it here. So now you can see that this resistor terminal 2 is connected to terminal 1 of this resistor. And let's grab a couple more, and we'll rotate and place that guy there, and one more. Rotate and place there. Now we have a series circuit. So we've got resistor 1, terminal 2 connects to resistor 2, terminal 1, resistor 2, terminal 2 connects to resistor 3, terminal 1, resistor 3, terminal 2 connects to resistor 4, terminal 1, and that is it. Okay. Now we want to give these resistors some values. So let's left click the resistor, and this is by default it's 1 kilo ohm. I'm going to make this ohms and change this to 820, so it'll be 820 ohms. And notice what happens, the the color code changes. So when you type in the value, it updates the color bands of the resistor. And let's do the same thing here. So let's maybe make this one 220. So 220. Let's make this one. Let's leave this one at kilo ohms, and let's make it say 1.2. Or let's make it 1.6 kilo ohms. 1.6 kilo ohms, and then this guy. Let's make this one back to ohms, and say 470. So we've got 820, 220, 1.6K, and 470. All right, so we've placed the breadboard, we placed the resistors, and they're all connected in series. So now we need to get a power supply. So we need a power supply. So again, left click and drag. And we're going to set this voltage at 12. We got 12. And I'm going to just kind of move this guy up here. Kind of zoom a little bit. All right, that's good there. Okay, so what I want to do now is I'm going to actually connect the power supply to, I'm going to connect the positive to the positive rail, the negative to the negative rail, and then run a wire to the circuit for both the positive and negative. So let me go ahead and do that. So the way you place wires is just left click, and you can see there that the end point of the wire becomes a square, and you can see how that rail is all highlighted. So that's where I want to connect it. So I'm just left click and then change this to red just to show that it's power. Okay, and we're going to do the same thing with the negative, but we're going to bring this to the top rail and change this to black. Okay, so now I'm running my positive to the positive rail, my negative to the negative rail, and now I need to bring this over and connect the positive to this column 5. I'm going to change this to red, and same thing on this side. I'm going to connect this to the negative and change that to black. And that's it. That is it. So we've created a series circuit, and we have power. So let's go ahead and start simulation. Okay. You can see here that it's 12 volts, which is what we set it to, and this circuit is drawing 3.86 milliamps, and so that tells us what the total current is. But what we really want to look at are the individual voltage drops. So for that, we're going to need a meter, a multimeter. So we're going to grab this multimeter, bring it over here, and for the mode, we want to keep the mode to be voltage because we want to measure the voltage drops across each resistor. So we go ahead and connect these. So let's grab positive of the meter, and we want to connect that to the higher potential, which will be the left side of this resistor. Okay, and straighten that up a little bit. like so. And the black, same thing. So the way you want to do this is just left click whenever you want to make a turn. You just left click and then connect it where you want it to go. So let's make that black. So now I've got the positive of my multimeter connected to the left side of resistor 1, the negative connected to the right side of resistor 1. So now I can go ahead and simulate, and you can see that I've got a 3.16 volt drop. I'm going to go ahead and record that 3.16 drop. The reason I'm doing that is because when I'm finished, I want to add them all up to make sure I get 12 volts to satisfy Kirchhoff's voltage law. So let's go ahead and stop simulation, and I'm going to left click on this wire and then hit delete. Same thing here. Now I'm going to connect this to resistor 2. So resistor 2, we're going to make that red, and connect the black. Connect the black to the other side of resistor 2. So I'm going to make that wire black. So the colors of the wires are just for visual purposes. It's has nothing to do with the operation of the circuit or the measurements. Let's go ahead and run the simulation. Now this one's only 849 millivolts, so 849 millivolts will be 0.849 volts. Stop simulation. Delete the wires. Now we're going to connect to resistor 3. So here's resistor 3. Make that red. Left click here. Pull that over a little bit. And left click. Make the sky black. Start simulation. 6.17 volts. 6.17 volts. Stop simulation. Delete wire. And finally, we'll do resistor 4. So make that red. And connect to the other side. So now I've got the red connected to the terminal 1 of resistor 4, and the black is connected to terminal 2. Start simulation. Get 1.81 volts. Okay, so let's add these up. 3.16 plus 0.849 plus 6.17 plus 1.81. We got 11.989 volts. So that's very, very, very close to 12. So we're off by 11 thousandths of a volt. So that's what, 11 millivolts out of 12 volts. So it's very, very close. It's essentially 12. Okay, so we've we're done. Now, one other thing you can do is you can also measure current using the meter. It's a little more tricky because to measure current, you have to actually break or open the circuit and insert the meter in series. Now, when you're measuring voltage, the circuit stays intact, and you just basically place the meter in parallel with whichever component that you want to measure the voltage across. But for current, you've got to actually um, alter your circuit by opening the circuit. Now I could open it here, 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 here. I can open it at any point. It's a series circuit, so it's going to have the same current. But probably the easiest is just to go ahead and open it right here at the start. So I'm going to delete this wire, and I'm going to run a wire directly to the meter. Okay, so now the current's going to flow out of the power supply, and the only connection on this rail is to the meter. So the current's going to flow into the meter and then out of the meter to the start of the circuit. So once the current flows into the meter, it's going to flow out of the meter and then flow into resistor 1, and then resistor 1 it'll flow into resistor 2, and then all the way back to here, back to the power supply. And the other thing is we've got to change this from voltage to amperage. So this needs to measure current. So if we start simulation, then you can see we get 3.86 milliamps, which matches what's coming out of the power supply. So we've got 3.86 milliamps flowing into the circuit and flowing through the circuit and then back to the power supply. Okay, I think that's good for this video. This is just a quick introduction to just a basic DC circuit with resistors in Tinkercad, and it's actually pretty useful. This shows you how to place components on a breadboard like you would do in an actual physical laboratory, and connect up a meter and a power supply. So that will finish this video, and I hope that you found this useful.